Hello, I'm Richard Patterson and welcome to another IPC Irwin video for teachers and technicians. We're looking at the Geiger-Müller tube and the counter, and this is the device that detects the radiation. It's got a lead which we connect to the GM connection on the counter there, and we mount it using this boss underneath. Now we tend to use this Geiger-Müller tube in three ways. We can hold it horizontally and bring up a radioactive source to the window. That's at this end of the tube, and we have to remove this cover, revealing a window into the tube made of quite a fragile material called mica. I have to be very careful with moving and storing this because that's quite delicate and it's easily broken, and if that happens then unfortunately the tube can't be repaired. So I'll just place that back on and secure it in a retort stand. So if we switch on the counter, we set the voltage on the tube to around 400 volts, and with this set on count with the sounder on, we should hear a little beep, and the counter should register it when we get ionizing radiation coming in there and causing the detector to pick that up. So if we just leave that there, it will measure the background count wherever you are. What I'll do now is just quickly demonstrate using a standard radioactive source. To use these, all staff and technicians should have been briefed by the radiation supervisor in your organisation, who should have attended the nationally prescribed courses, which in England are run by the ClearUps organisation. So I've taken out the source from the radioactive storage cupboard, which is on site, and I'm logging the use of the source, the time I've taken it out and the time I will return it in this file here. I've removed the source from its casket. There's a metal lead container there where it is usually stored, and I'm using these long forceps to handle it. So gripping that carefully, I'll bring it up to the window, and immediately the count increases dramatically because this is giving out alpha radiation, and these are helium nuclei and have a great ionization, and that's producing the great radio count. Now if I withdraw that and put a little bit of air in between, you can see the count drops. I'll place that back in the box and put the lead cover on. One thing about this arrangement is that the radiation, although it is alpha and is being absorbed by the air, is streaming across my bench. So one recommendation is to tilt the Geiger-Müller tube vertically, so that if we mount the radioactive source on the retort stand pointing upwards, any onward radiation will go up into the air and not impinge on people around the room. That's particularly important when we're using the radiation sources that have a greater penetrating distance, such as gamma. One wonderful experiment we can try with the Geiger-Müller tube and the counter is to see how the distance of the radiation from this americium sources is affected by distance from the Geiger-Müller tube. So to do that, we've set the Geiger-Müller tube horizontally. If we remove the protective window with the americium source safely in its lead storage container, the tube is now picking up the background count from the locality. And if we look at the counter, we have it on the count rate, and so far we've registered 7 ionisation events whilst we've been talking. Now what we will need to do is to get the actual rate per second. So if we switch it to there, that will be the rate per second, and it's 10 to the 3. So we'll just let that pick up background radiation. It's usually around 1, and the machine is picking that up and showing a counter between 0 and 1. So we'll take the background count rate as being 1, and we need to subtract that from the count that we get from the americium source. So to carry out the investigation, we're going to use this holder for the source. It's a magnetic slider there, which has got a screw on. It slides along there, and we've got a millimetre scale just below on the radioactive bench, and we can work out how far away the source is from the Geiger-Müller tube's entry mica window there. So if we place that on the bench and take out the source, we're going to use the bulldog clip to secure it to the holder. So if we place the metal holder over the americium source and use the bulldog clip, that's now going to safely hold that for us. Got to make sure it's firmly in there. And remember, we don't want the radiation coming out of the little window in the source's holder to be aiming at people, and people observing this need to be at least 1 metre away. And if you've got any female adults in the room, got to check if there's a chance that they could be pregnant. All this is in the regulations on the course that your radiation supervisor will have taken. So if we place that on the radioactive bench there, what I'm going to do is slide it right up to the window. I don't want it to touch the window, I don't want to damage the window in any case, but if we bring that as far as we can and record the rate per second, which is looking like around 800. So we'll record that and note the distance from the Geiger-Müller tube to the front. And what I'm going to do is just slide this back in increments, and at each time record the count rate of the americium. So we do that until the count rate goes down to background count, which remember was about 1. That's normally about over 7-8 centimetres, and still ticking away there. And we're going to plot a graph of distance against count rate. And this shows you that the alpha particles emitted by this source are absorbed by the air, and as we remove it further and further away, we should eventually get down to the background count. Well, thank you for watching this video featuring our Geiger-Müller tube and our counter. It's worthwhile mentioning there is a version of the Geiger-Müller tube that's got a smaller mica window there, and we've mounted that in a standard retort stand boss and clamp. We have to be quite careful not to squeeze the tube too much. All the instructions for this equipment are on our website if you follow this QR. They're quite extensive in this case, and again, if you go to the Institute of Physics Spark site, there's a large variety of experiments and investigations to do with radiation, radioactivity for you to follow if you need some detailed teaching notes.